This is a look at factoring our first type of trinomials, and they're really called simple trinomials because they don't have a coefficient or they don't have a number in front of the first term. Now the format of these problems is going to be like this: x squared plus b times x plus c. B and c are numbers, and x is always the unknown. And we always write them with the highest exponent first, and we go in decreasing order for exponents. So let's take a look at what we do first. First, we're going to factor trinomials into a binomial times a binomial. Now, when I do that, the first thing I have to decide is what signs, what operations are in the middle of these binomials. So we'll create the binomial pairs, and then we'll set the signs. What I do to find the sign is the first rule. The first rule says look at the second sign in the trinomial. If the second sign is positive, then both of your signs are going to match whatever the first sign is. In other words, since the second sign was positive, both of my signs matched the first sign. In this case, it was positive, so both of them were positive. Next example, 2x minus bx plus c, the second sign is positive, so it points me toward the first sign. It's negative, so I'm going to have two negatives. That's the first way to set your signs. The third case is rule number 2. What if the second sign is negative? When the second sign is negative, you don't even care what the first sign is. It doesn't matter. You're going to use one of each sign. No, it doesn't matter if it's plus, minus, or minus, plus, but I'm always going to stay consistent with this, and I'm always going to place it plus, minus when it's one of each. Now, after I've set my signs, I want to create something that I'm going to call the factor statement. Rule number 3 says use the second operation to find out if you add or subtract the factors to equal b. Well, that's the factor statement, okay? So what it does, it says look at the second operation. This one tells me add, and I'm going to say I need to add to equal whatever the coefficient of the middle term is, or b, right? b in this case is 7. So my factor statement for this trinomial says add to equal 7. What do I want to do first? I want to create the binomial pairs and set the signs. My second operation in this case was positive, so it told me look at the first one, and the first operation was positive. I'm going to use both positives. The next thing I do is to factor the variables that are squared. That's step 3. Now in this case I only have x squared. X squared factors into x times x. Since it's in the first position of the trinomial, I'm putting it in the first positions of my binomial pairs. Well, I'm done with that term. Now I have to factor the c term. Remember, this is a, this one in the middle is b, and the third one is c. The c term, what is c? Well, c is equal to 6. And I need to find factors of 6. Well, 1 times 6 and 2 times 3. Do any of those factors add together to equal 7? Remember, my factor statement is what I'm trying to find. Add to equal 7. Well, 1 times 6 would add to equal 7. 1 plus 6 equals 7. So those are the numbers I need. Where do they go? Well, they go in the second positions, the only blanks that I have. And I'm going to put them in the same order, because that'll help me later on when I'm doing complicated trinomials. And then I have to FOIL to check this one. So I say, first, x times x gives me x squared. Check that one off. And I say last, I'll go ahead and do first and last because they're the easy ones. 1 times 6 gives me 6. I'll check that block off. The middle terms are the ones that give me trouble. I have to say 1 times x is 1x. And then outside terms, x times 6 is 6x. I'll combine those to get a positive 7x, and that is what my middle term is. So I've checked it. You should follow these same steps. Always remember to FOIL to check, because it's very important, your trinomial, to make sure you've done your trinomial correctly. Example number 2 is another simple trinomial. Let's see if we can follow our steps and go ahead and set the factor statement. I look at the second operation and I say I need to add to equal whatever the coefficient of the middle term is. So I need to add to equal 6. Now remember, I don't have to worry about the signs because I'm going to set the signs. So I don't have to say add to equal a negative 6 up here. Add to equal 6 will be fine. Next I'm going to set the signs. I look at the second operation. It tells me that it's a plus. So it tells me to use the first operation for both signs. Both signs are going to be negative. I next do step 3 factor the variables that are squared. Well, x squared is the only square I have. It factors into x times x. I look and I say c is really equal to 9. So I'm only interested in factors of 9. Well, that's just, there are only a couple of them, 1 times 9 and 3 times 3. And these, which ones add to equal 6? Well, 1 plus 9 does not equal 6, so that one doesn't work. 3 plus 3 does equal to 6. So that's the pair I need. Let's circle the ones I need. I'm going to use those in the last positions. And then I'm going to check it by foiling. X times x is x squared. Negative 3 times negative 3 is positive 9. You see my signs were set correctly. Negative 3x is the inside terms. Negative 3x is the outside terms. I combine those to get a negative 6x. Sign is important here. Negative 6x is my center term, so I have factored it correctly. Let's look at number 3. This time it's a little bit different. It has an x squared at the beginning and a y squared at the end, and the middle term is xy's, but still, it's going to be basically the same rules. Let's try our factor statement. It says add to equal 8. Remember, add is the second operation. 8 is the coefficient of the b term. Next, let's set the signs for the factors. That second operation is positive. It tells us to use the first operation for both signs, so we'll use positives. Let's factor the x squared term. And now let's add something in here. It says factor the variables that are squared. Well, we have two variables that are squared. Y is also squared. So we're going to factor it, and we're going to put it right here at the end. We have to leave room in front of it to write a coefficient, though, okay? Now next, let's just follow our steps. What is C? Well, C is the number 15. And let's see if I can come up with factors of 15. 1 times 15 and 3 times 5 there just aren't too many. Do any of them add to equal 8? Well, it looks like 3 plus 5 would equal 8. So those are the ones I want. I'll put them in my second positions. And then I need to FOIL to check this. X times x, x squared. 3y times 5y, 15y squared. Now your first and your last almost always work, so it's a good idea to just go ahead and check them quick and get them out of the way. Then let's do inside. 3y times x, well, let's write it 3xy alphabetically, okay? And then x times 5y would be 5xy. Those are both positive, so when we add those terms together, and we can because they're both the same variables, aren't they? We get 8xy. So we have FOILed it, checked it, and we factored it correctly. Example number 4 is just really not written in a format that I like. So I see that the x squared is at the end, and my plain number term is at the beginning. Can I rearrange this? Well, yes, you can. As long as you keep the signs with the terms, you can move them wherever you want to. I'm going to say x squared plus 14x plus 13 is a better format for me to factor. Now, I can go ahead and say, what is my factor statement going to be? Well, I look at the second operation, and it says add to equal the b variable. So it's the coefficient of the b term. Remember, that's my b term. Add to equal 14 is what it says. Let's go ahead and set the signs for the factors. The second operation is positive, so it points us toward that first operation, doesn't it? The first operation is positive. We use positives for both. We factor the x squared, the variable that's squared next. And then we're going to factor c. C is 13. Well, 13 doesn't have many factors, does it? 1 times 13 is it. But fortunately, 1 times 13 really does add up to equal 14. So we'll use 1 and 13. Now let's check it. X times x, x squared. 1 times 13, 13. 1 times x, 1x. X times 13, 13x. Your answer, when we combine like terms, 14x, and that is the center term of our trinomial. Now, the next example, example 5, looks like it might not be able to factor so easy. But we have to remember the first step of any factoring problem. What is it? It's to factor out the greatest common factor, or to factor out the GCF. If I look, I see that these three terms do have something in common. They have the number 4, and they have the variable y. Once I factor that out, I might have a simpler trinomial. Let's see what we have. Y to the 4y times x squared would give me 4x squared y, so that's my first term. 4y times a positive, just plain old x, would give me 4xy, so that's my second term. And 4y times a negative 2 would give me that negative 8y. So really all I have to do is remember my 4y is my first term multiplied times, let's just factor the x squared plus x minus 2. The factor statement this time, second operation, remember, says subtract to equal the coefficient of the middle term. Now remember, we're not working with this one that has the complex trinomial, that has the GCF inside it. We're working with the second one, the one we pulled the GCF out of. So I'm going to say subtract to equal 1. There's nothing in front of the x, so therefore it's understood to be a 1. Next, I'm going to set the signs. The second operation, the sign is negative. That tells me use one of each. And like I told you, I'm always going to do positive, then negative. Next, step 3, factor the variables that are squared. X times x would give me the x squared. And now all I have to do is factor c. Now, I've already set the sign, so I don't have to worry about the fact that it's a negative 2. I just have to say, does it have numbers that I would subtract to equal 1? Well, it does. 2 minus 1 would equal 1, wouldn't it? So these will work. I'll put a 1 and a 2 in, and I really have to be careful when I FOIL it because I have opposite signs. So first I say x times x, x squared. 1 times negative 2, negative 2. Now just because those work doesn't mean that the middle two are right, so there's where we usually have our problems. 1 times x gives me a positive 1x. X times negative 2, a negative 2x. Well, when I subtract, that gives me a negative 1x or a negative x. That is not what I need for this center term. I need a positive x. So what do? Here's the trick. Just flip the signs. Don't go moving the numbers around. Just flip the signs. Check that inside and outside again. This time I say negative 1 times x gives me a negative 1x. X times 2 would be a positive 2x. When I combine those, I'll end up with a positive 1x, and that is what I need. So, if you have one of each sign, be careful when you FOIL that you check the inside and outside terms very carefully. And if you have the sign wrong, just flip the signs. Don't move the numbers.